Welcome to this lesson of linear algebra. So in this video, what I'm gonna go through is what we call linear combination and span. Okay, so I have some few definitions I want us to go through of them. So we have a vector space V. Okay, over a field. This is just a field. You can think of a field as scalars, right? So at this moment, let's think of it as a scalars, and we have some particular set. Okay, so it's just set of vectors S, and being a subset of V that is non-empty as well. We say that a vector V, right, which is in the vector space, is a linear combination of vectors of this set, right? If there exists some vectors in the set, I said first that the vector S is not empty, right? So there are some vectors in there and then some scalars, right? So you can think of some numbers, or maybe it can be complex numbers or real numbers, so that you can write that little v, this guy here, which is in the capital V, as a linear combination, as a sum of scalar multiple of the vectors in S. So you have some number times the first vector, which is u1 in S, plus some number times u2. So these guys are vectors, right? You can have as many as you want, right? And then these are just numbers, so that's what you can think of them. Then we can say that V is actually a linear combination of vectors in S. So if you can write V as some scalar multiple, or the summation of scalar multiple of the vectors in S, then V is a linear combination of element in S. So an example that I gave was, you can pick the capital V, which is the vector space we are looking at as the two-dimensional vector space, R2, and then you can pick this S as a subset of the R2, because this whole thing, everything you have here belongs to R2, because this is a two-dimensional vector, right? And this is also a two-dimensional vector. So they are specific vectors that I've picked from in R2. And if I'm able to say that I have a vector small v, which is 2, 1 in R2, then this 2, 1 can be written as some scalar multiple of the vectors you have here, and then you sum them, right? So you realize that you can write 2, this 2 that you have here, as just 2 times the vector 1, 0 from the set S, right? So here can you identify u1 and u2? Assuming that the vectors in S are called u1 and u2, here you can choose to say that my u1 is actually the vector 1, 0, and then my u2 is equal to the vector 0, 1, right? So you can say that this little v we have is actually 2u1 plus 1 times u2, right? So here this will correspond to a1 and this will correspond to a2. So if you had maybe S to be many, then we're going to have a lot of them, right? So basically that's the whole idea about linear combination, right? Now let's talk about the span. The span of S here, denoted as span S, is a set of all linear combinations of vectors of S you can think of, right? So what I'm saying is, every combination that you can get out of the set of vectors in S, each one of them, all the set of the combinations you can get, is what we call the span. And an example for you to understand what I'm saying is that, again, taking the same vector S, then the span of S is all the set in this form: a1 times 1, 0, a2 times 0, 1. And in this case, a1, if a1 is equal to 0, and then if a2 is equal to 2, we will get what vector? What vector are we going to get? We're going to get 0 into 1, 0, plus a2 is 2, so I'll put 2 here, 0, 1, and that's going to give me 0 times everything here is going to be 0, so I'm going to get the 0 vector, right? And then if I add it to this guy, I'm going to 0, 2. If I add these two vectors, I'm going to get 0, 2. So 0, 2 actually belongs to the span of S, because you can write this vector 0, 2 that we've gotten here as 0 times the vector here u1, let me put it that way, and this 2 times u2. So if a1 is negative 1 and then a2 is 3, what will you get? You're going to get negative 1 into 1, 0, plus 3 into 0, 1, and this is going to give us what? Negative 1, 3. And this belongs to the span of S, right? So what the span means is just whatever combination you can get, right? So that it will give you some vector. So if I tell you that the vector 1/2 and 2 actually belong to the span of S, this is true because this 1/2 2 as a vector can be written as 1/2 multiplying 1 0 plus 2 multiplying 0 1, right? And if you do this calculation, you're going to get 1/2 2 as a vector, right? So all the possible combinations you can get for this, set of vectors u1 and u2 in this S is what we call the span of S. Ideally, actually, maybe in our next kind of videos, you're going to see that the span of this particular choice of my S vectors is actually R2. So with this example, the span of S here is equal to R2. I mean, every vector you have in R2 can be written as something multiplying this guy plus something, and that is a special case. All right, I'm going to give an explanation to that maybe in some other video, because you can think of the vector 0 0, it belongs to R2, right? But this 0 0 is the same as 0 times what we have here plus 0 times 0, that. And if you do this multiplication and add them, you're going to get 0. So, I mean, every vector you can think of is actually a scalar multiple, or maybe belongs to the span of this in terms of R2. Now, if S spans a vector space V, then all vectors in V are written as a linear combination of vectors in S. I mean, that's what I said. And exactly that's what I have here. All right, so if I have S to be 1 0 0 1, then S spans V, right? V equals R2. So what I'm trying to say, or what I actually said, was every vector you have in R2, if you have a little vector in R2, then that vector can be written as some linear combination, maybe A0, that, plus another constant, maybe that, right? And here you can think of other examples. You can think of the example 1 2, which is a vector in R2, and this negative 1 2 here is equal to negative 1 into 1 0 plus 2 into 0 1. I mean, there are some set of vectors like this S here is so easy to come up with the scalars you can put in front of these, but there are some vectors that when you have them you cannot just guess. So the ideal situation was supposed to be, maybe if I ask you 3 2, is it in the span? How you're gonna solve this problem? It would be like, you can be asked that, is 3 2 a member of the span of this S, right? And the span of this S means that can 3 2 be written as a scalar multiple of, elements in, or maybe the summation, linear combination, let me put it that way, linear combination of elements in X. All right, so this is what you're going to do. And if you do this calculation, we're going to have 3 2 to be equal to A times that. I'm going to get A here, and then A times 0 is 0, plus B times, I'm going to get 0, then B, right? If I add a right, I'm going to have A plus 0, so I'm going to have A here, I'm going to have B here as well, and this is equal to 3 2. So we just do comparison and say that, okay, A should be equal to 3, and then B should be equal to 2. That's why normally when I just write it, I know that here I'm going to have my A to be negative 1, and here I'm going to have my B to be 2. So if you have just 3 2 is the same as 3 into 1 0 plus 2 into 0, and this is, like I said, a special case. Alright, so I'm going to talk about next thing, maybe basis or something else in our next video. So kindly subscribe to my channel if you have not subscribed, and see you in our next video.